1. Concrete grinder. How it works and its output. Intro. Background music. Footage of a construction site. Welcome to another episode from Civil Engineering Edge. Today, we dive into advanced construction equipment, starting with the concrete grinder, a powerhouse tool used to level, smooth, and clean concrete surfaces. Scene showing a concrete grinder in action. So, how does a concrete grinder work? A concrete grinder uses rotating discs or pads embedded with industrial-grade diamonds. These discs spin at high speed to grind, polish, or remove coatings like epoxy, glue, or paint from concrete floors. There are two main types: handheld grinders for small areas and walk-behind grinders for larger floors. The grinding action happens as the diamonds cut into the concrete surface, gradually smoothing it down. Some grinders come with wet or dry grinding options. Wet grinding uses water to reduce dust and cool the blades, while dry grinding uses a vacuum system to collect dust on the go. The tool usually runs on electricity or gas, depending on the model, and may include variable speed controls, adjustable handles, and even dust shrouds for safer operation. Scene shift before and after shots of a polished concrete floor, and the result: a concrete surface that's even, smooth, and ready for coatings or polishing. The output can vary from light surface cleaning to a mirror-like finish, depending on the grit size used. Concrete grinders are vital in flooring work, renovation, and even road repair. They increase efficiency, reduce labor time, and ensure a professional finish. Outrow, logo plus subscribe button animation. That's how a concrete grinder works. Stay tuned as we explore more advanced tools. Next up, the Diamond Concrete Core Drill. 02. Diamond Concrete Core Drill. How it works and its output. Intro. Action shot of a core drill cutting through a concrete wall. Welcome back to Civil Engineering Edge. In this segment, let's explore the Diamond Concrete Core Drill, a precision tool designed for creating perfectly round holes in the toughest concrete surfaces. Scene shows the setup of a core drill with diamond bit. So, how does it work? A diamond core drill operates by rotating a hollow cylindrical drill bit embedded with industrial diamonds at its cutting edge. These diamonds give it the ability to cut through reinforced concrete, masonry, stone, and asphalt with ease. The drill is typically mounted on a rig or stand for stability, and it may use either electric, hydraulic, or pneumatic power. Water is supplied to the drilling area to cool the bit, reduce friction, and control dust. The core bit cuts through the concrete in a circular motion, and instead of pulverizing the material like standard drills, it removes a solid cylindrical core, leaving a clean, smooth hole behind. Cut to footage of cylindrical concrete cores being removed. What about the output? Diamond core drills can produce holes ranging from 1 inch to several feet in diameter and depths of up to 10 feet, depending on the bit and machine. The holes are precise and clean-edged, making this tool ideal for installing pipes, ducts, wiring, anchor bolts, or even testing material samples. It's highly valued for its speed, low vibration, and minimal structural damage, especially in renovation or retrofitting projects where accuracy is crucial. Outrow, close-up of finished holes, fade. It's the Diamond Concrete Core Drill in action. Coming up next, the air-powered chainsaw. Stay with us. 3. Air-powered chainsaw. How it works and its output. Intro footage of workers using air-powered chainsaws in demolition. Welcome back to Civil Engineering Edge. Next in our series of advanced construction equipment is the air-powered chainsaw, a rugged, high-performance tool used for cutting concrete, metal, wood, and more, especially in hazardous environments. Scene shows close-up of the air chainsaw's components. So, how does it work? An air-powered chainsaw, also called a pneumatic chainsaw, uses compressed air instead of electricity or fuel. This air is supplied by an industrial-grade compressor through a connected hose. The compressed air drives a piston motor inside the saw, which rotates the chain around the guide bar at high speed. The cutting chain is made of hardened steel or diamond-tipped teeth, depending on the material being cut. Because there are no electrical components, air-powered chainsaws are spark-free, making them perfect for use in flammable or explosive environments, like oil refineries, chemical plants, or confined spaces. Cut to the tool slicing through thick concrete and metal pipes. And what about the output? These saws are incredibly powerful and durable, capable of cutting through reinforced concrete, steel, and timber with precision. They produce minimal heat and have low maintenance requirements thanks to their simple internal design. The output is clean, fast, and efficient cuts often used in emergency rescue, demolition, and industrial decommissioning. They're also used underwater as they don't rely on electrical circuits. Scene: worker easily handling the saw with protective gear. Safety, speed, and reliability. That's the air-powered chainsaw for you. Tool on. Display subscribe button up. Next, the Combustible Dust Vacuum Cleaner, a critical tool for maintaining safety in construction sites. Don't miss it. 04. Combustible Dust Vacuum Cleaners, how it works and its output. Industrial setting with dust in the air, then a worker using a specialized vacuum. Welcome back to Civil Engineering Edge. Today, we look at a life-saving piece of equipment, the Combustible Dust Vacuum Cleaner. In environments where fine dust particles can ignite or explode, this tool plays a vital role in preventing disasters. Cut to animation showing how combustible dust accumulates. So, how does it work? Combustible dust vacuums are engineered to safely collect and contain fine, flammable particles like sawdust, metal shavings, or cement powder. Unlike ordinary vacuums, these are made with anti-static components, non-sparking motors, and grounded conductive hoses to eliminate any chance of static discharge. They often use a HEPA filtration system to trap microscopic particles, preventing them from recirculating into the air. Some vacuums operate in class to division to environments, areas where combustible dust is present under abnormal conditions. Many are pneumatically powered, meaning they operate on compressed air, avoiding any risk of electrical spark. Others use brushless motors and contain explosion-proof housing. Scene: workers safely vacuuming a large area filled with wood or cement dust. Now, what's the output? Combustible dust vacuums provide safe, compliant cleanup in high-risk industrial zones. They remove hazardous dust before it accumulates, reducing the risk of fire, explosion, or respiratory harm. This leads to a safer, cleaner work environment that complies with OSHA and NFPA standards. Their suction power and filtration efficiency are unmatched when compared to standard shop vacs, making them indispensable in factories, workshops, and construction zones. Clean workspace, safety signs, subscribe button. Next, the one-man polymer pump, a compact marvel designed for smart concrete repairs. Stay tuned. 5. One-man polymer pump, how it works and its output. Worker using a compact pump for crack injection in concrete. Welcome back to Civil Engineering Edge. Today's spotlight is on the one-man polymer pump, a game-changing tool for structural repair and waterproofing, especially in hard-to-reach areas. Scene shows the equipment setup, lightweight, portable unit. So, how does it work? The one-man polymer pump is a portable injection system designed for the precise delivery of epoxy or polyurethane resins into cracks, voids, or joints in concrete structures. The setup is simple and can be operated by a single person, making it perfect for tight job sites or minor repairs. The pump uses either a manual lever, electric motor, or air compressor to apply pressure to the polymer material. This pressure forces the resin through a hose and into a specialized injection port or packer that's pre-installed into the crack. Once injected, the low-viscosity polymer flows deep into the concrete fissure. It then cures and hardens, creating a strong bond that restores both structural integrity and watertightness. Scene: close-up of the crack sealing process, followed by hardened resin, and the output. The one-man polymer pump delivers precise, high-pressure injection with minimal material waste. It enables quick and effective repair of concrete cracks in foundations, basements, walls, and bridge decks. The result is a permanent seal that stops water intrusion and strengthens the structure from within. It's widely used in civil repair work, especially in tunnels, dams, parking structures, and high-rise buildings. Lightweight, efficient, and easy to carry, this tool truly empowers solo operators to do professional-grade repairs. Out row: worker packing up clean and restored concrete surface. Up next, the power sander, used not just for wood but also for concrete and steel surfaces. Let's keep going. 06. Power sander, how it works and its output. Intro: worker using a power sander on a wall and a concrete surface. Welcome back to Civil Engineering Edge. Up next in our Advanced Equipment series is the power sander, a tool that's essential for surface preparation, smoothing, and finishing work on wood, metal, concrete, and more. Scene: different types of power sanders, orbital, belt, and disc sanders. So, how does it work? A power sander is an electrically or pneumatically powered tool that uses abrasive-coated pads or belts to wear down surfaces through high-speed friction. Depending on the task, different models are used. Orbital sanders move in a circular motion, ideal for fine finishing. Belt sanders use a continuous loop of sandpaper for aggressive sanding. Disc sanders spin a flat abrasive disc for leveling large areas. Concrete sanders, specifically designed with diamond-coated pads to grind and smooth cement or stone. The motor drives the sanding surface, which removes old paint, rust, irregularities, or rough patches. Many models feature variable speed settings, dust extraction ports, and ergonomic grips for better control and user safety. Cut to sanding a rough concrete floor and then a smooth, polished surface, and the output. The power sander delivers smooth, even surfaces critical for painting, coating, or bonding. For wood, it removes imperfections. For concrete, it prepares the slab for sealants or adhesives. In metal work, it polishes surfaces or removes corrosion. It greatly improves efficiency and finish quality, reducing manual effort and labor time. With the right abrasive and settings, a power sander becomes a versatile tool across construction, carpentry, metal fabrication, and flooring industries. Out row: before and after surface shots fade into channel logo. And that's the power of a power sander. Coming up next, the automatic threading machine, a must-have for every pipe work expert. Stay with us. 7. Automatic threading machine, how it works and its output. Footage of threading machine operating on steel pipes. Narrator: welcome back to Civil Engineering Edge. In this final segment, we feature the automatic threading machine, a core tool in plumbing, firefighting systems, and industrial piping, where threaded pipe connections are essential. Scene: worker feeding a pipe into the machine. So, how does it work? The automatic threading machine is a heavy-duty device used to cut external threads onto metal pipes and conduits. These threads allow pipes to be securely joined with couplings or fittings. Here's how it works. 1. The pipe is clamped firmly into the machine's chuck. 2. The motor-driven head begins rotating the pipe. 3. A die head with cutting dies advances automatically onto the pipe. 4. The dies cut threads into the outer surface as the machine controls the feed rate for uniform, clean threading. These machines typically feature automatic lubrication, which keeps the dies cool and prevents metal buildup. Many also include auto-opening die heads that release the pipe when threading is complete, increasing efficiency. Automatic threading machines can handle a variety of materials: mild steel, galvanized iron, stainless steel, and even plastic pipes, with cut-to-pipe being threaded and then connected using fittings. And what's the output? This machine produces precise, consistent threads on pipes ranging from 1/2 inch to 4 inches or more in diameter. The output is clean, leak-proof joints that are ready for use in plumbing, gas lines, sprinkler systems, and structural piping. It drastically reduces labor time and increases threading accuracy, especially for large-scale projects and on-site fabrications. Out row, piles of threaded pipes ready for use. And that wraps up our look at advanced construction equipment. Like, share, and subscribe for more real-world engineering insights, only on Civil Engineering Edge. Oh wait, Apogee Ultra Robotic Exoskeleton, how it works and its output. Worker donning. The exoskeleton, lifting heavy materials effortlessly. Welcome to Civil Engineering Edge. Today, we spotlight the Apogee Ultra Robotic Exoskeleton by German Bionica, revolutionary wearable that enhances human strength and endurance on construction sites. Scene: close-up of the exoskeleton's components and its integration with the human body. So, how does it work? The Apogee Ultra is a powered exoskeleton designed to support workers during physically demanding tasks. Equipped with AI-driven adaptive support, it provides dynamic assistance tailored to individual movements. The exoskeleton can reduce the strain of lifting up to 80 pounds, making a 70-pound load feel as light as 8.8 pounds on the lower back. Its active walking support feature makes traversing long distances less taxing, and it offers relief during bent-over tasks, enhancing comfort and productivity. The device continuously learns and adapts through machine learning, ensuring optimal support over time. Scene: worker performing repetitive tasks with reduced fatigue. And the output: by mitigating physical strain, the Apogee Ultra reduces the risk of injuries, decreases fatigue, and extends the working life of construction personnel. It enhances overall productivity and allows workers to perform tasks more efficiently and safely. Out row, worker completing task with ease. Next up, we explore the Adapt autonomous forklift, a game changer in material handling on construction sites. 9. ADAPT autonomous forklift, how it works and its output. Intro: the ADAPT forklift navigating a busy construction site autonomously. Welcome back to Civil Engineering Edge. Let's delve into the Adapt autonomous forklift, a pioneering solution addressing material handling challenges in dynamic construction environments. Scene: the forklift sensors and navigation systems in action. So, how does it work? The Autonomous Dynamic All-Terrain Pallet Transporter, ADAPT, is engineered to operate in unstructured and ever-changing construction sites. It integrates AI-driven perception systems, including cameras and sensors, to navigate complex terrains, avoid obstacles, and make real-time decisions. Unlike traditional forklifts, ADAPT doesn't require human intervention. It can autonomously pick up, transport, and place materials, adapting to varying weather conditions and site layouts. Its robust design ensures stability and efficiency across different terrains. Scene: ADAPT transporting materials seamlessly across the site. And the output: ADAPT streamlines on-site logistics, reducing reliance on manual labor and minimizing delays. It enhances safety by removing human operators from potentially hazardous tasks and environments. By ensuring timely and precise material handling, ADAPT contributes to maintaining project schedules and improving overall site productivity. Adapt completing tasks efficiently. Stay tuned to Civil Engineering Edge for more insights into the future of construction technology. 10. Concert Modular reconfigurable robot, how it works and its output. Footage of the concert. robot adapting to various construction tasks. Welcome to Civil Engineering Edge. Today, we spotlight the Concert Modular reconfigurable robot, a groundbreaking innovation designed to revolutionize on-site construction tasks through adaptability and collaboration. Scene: close-up of Concert's modular components being assembled. So, how does it work? Developed by the Humanoid and Human-Centered Mechatronics Laboratory at the Istituto Italiano di Tecnologia, Concert is a modular collaborative robot cobot engineered for versatility on construction sites. Its design allows for rapid reconfiguration by adding or removing passive or active modules, enabling it to perform a wide range of tasks such as drilling, sanding, plastering, and collaborative transportation. The robot's software pipeline automatically updates its kinematic, dynamic, and geometric parameters based on the installed modules, ensuring optimal performance for each specific task. Scene: Concert performing various tasks: drilling, sanding, and transporting materials. And the output: Concert delivers high adaptability and efficiency in performing multiple construction tasks. Its ability to be reassembled and made operational in less than 10 minutes allows for quick transitions between tasks, reducing downtime. By acting as a co-worker or operating autonomously, Concert enhances productivity and safety on construction sites, especially in scenarios requiring precision and flexibility. Arxiv. Outrow: Concert completing tasks seamlessly. Next. The Leva High Mobility Logistic Vehicle, a game changer in material transportation across challenging terrains. 11. Leva High Mobility Logistic Vehicle, how it works and its output. The Leva vehicle? Navigating rugged construction terrain autonomously. Welcome back to Civil Engineering Edge. Let's delve into the Leva High Mobility Logistic Vehicle, an innovative solution designed for efficient material transportation in challenging construction environments. Scene: close-up of LEVA's legged suspension system and cargo handling mechanism. So, how does it work? LEVA is a high-payload, high-mobility robot engineered for autonomous logistics across varied terrains typical in construction sites. It uniquely integrates an advanced legged suspension system using parallel kinematics, allowing it to traverse stairs, uneven surfaces, and inclines. Equipped with steerable wheels and a specialized box pickup mechanism, Leva can autonomously load and transport payloads up to 85 kilograms, maintaining stability and efficiency across challenging terrains. Scene: Leva autonomously loading and transporting materials across a construction site. And the output: Leva provides reliable and precise cargo transportation in environments where traditional wheeled vehicles may struggle. Its ability to navigate complex terrains autonomously reduces the need for manual labor, enhances safety, and ensures timely delivery of materials, thereby improving overall site productivity. Leva completing a delivery. Fade to channel logo. Stay tuned to Civil Engineering Edge for more insights into the future of construction technology. 12. Built Robotics Exosystem, how it works and its output. Footage of heavy machinery operating autonomously on a construction site. Welcome to Civil Engineering Edge. Today, we spotlight the Built Robotics Exosystem, a revolutionary retrofit kit transforming standard construction equipment into autonomous machines. Scene: close-up of the Exosystem components being installed on an excavator. So, how does it work? The Exosystem is an aftermarket solution that integrates advanced hardware and software into existing heavy equipment. It combines GPS, cameras, and artificial intelligence to enable autonomous operation. Once installed, the system allows machinery like excavators and bulldozers to perform tasks such as trenching, grading, and earth moving without direct human control. Operators can monitor and manage these machines remotely through a user-friendly interface, ensuring precision and safety on the job site. Wikipedia. C. Autonomous excavator performing precise digging operations. And the output. By automating repetitive and labor-intensive tasks, the Exosystem increases productivity, reduces labor costs, and minimizes human error. It also enhances safety by removing operators from hazardous environments. This technology is particularly beneficial in large-scale projects where efficiency and precision are paramount. Overview of the autonomous equipment operation. Next up, we explore the dual power shift electric tool line, a game changer in sustainable construction practices. 13. Dual power shift electric tool line, how it works and its output. Intro. Workers using dual electric tools on a construction site. Welcome back to Civil Engineering Edge. Let's delve into the dual power shift electric tool line, an innovative step towards eco-friendly construction. Scene. Demonstration of various power shift tools in use. So, how does it work? The power shift line replaces traditional gasoline-powered tools with battery-operated alternatives. Utilizing a 554 watt-per-hour battery, these tools deliver performance equivalent to 6.5 horsepower. The lineup includes equipment such as plate compactors and core drills, designed to meet the rigorous demands of construction work while reducing environmental impact. Time. Scene. Comparison between traditional gas-powered tools and power shift electric tools, and the output. Dual's power shift tools offer a 60% reduction in CO emissions compared to their gasoline counterparts. They also produce less noise, contributing to a more comfortable and compliant work environment. These tools maintain the power and efficiency professionals expect, making them a sustainable choice without compromising performance. Time. Outrow. Workers efficiently completing tasks with power shift tools. Please don't forget like, comments, share, and subscribe to our channel. Stay tuned to Civil Engineering Edge for more insights into the future of construction technology.